Hello everyone, this is Akanksha Singh Gautam and I am here to be your instructor for the next few lecture series on biomedical instrumentation and sensor. Today we are going to discuss about wearable sensors and devices. By the end of this session, student will be able to identify and describe different types of wearable sensors and devices in biomedical instrumentation and sensors. Let's start with a quick warm-up activity. I will display a series of images of different wearable devices. Your task is to identify and list as many devices as you can. Let's begin. So, do you know which of the following wearable sensor is most commonly used in healthcare? Your options are ECG sensor, temperature sensor, accelerometer, pulse oximeter. The correct answer is D, pulse oximeter. It is widely used to measure oxygen saturation levels in the blood and heart rate. Now, let's officially begin our lesson on wearable sensor and devices. First, let's understand what wearable sensors and devices are. Wearable sensors are electronic devices designed to be worn on the body or integrated into clothing, allowing them to collect data about various physiological and environmental parameters. Wearable devices have become increasingly important in biomedical instrumentation and sensor as they offer real-time monitoring and provide valuable insights for healthcare professionals. Now that we have a general understanding of wearable sensors and devices, let's explore the different types of wearable sensors used in biomedical applications. I will present a list of these sensors on the screen and we will discuss each type, its purpose and functionality. An ECG, electrocardiogram sensor, is a medical device used to measure and record the electrical activity of the heart. It is a vital tool in cardiology and is widely employed in medical settings and even some consumer wearable devices. The ECG sensor detects the electrical signals generated by the heart's muscles during each heartbeat and converts them into a visual representation known as electrocardiogram. Next, a temperature sensor is a type of electronic device used to measure and detect the temperature of its surroundings. It is widely used in various applications including industrial processes, environmental monitoring, consumer electronics, medical devices and more. Temperature sensor play a crucial role in ensuring precise temperature control, safety and efficiency in a wide range of systems and devices. Next, a pulse oximeter. A pulse oximeter is a medical device used to measure two vital parameters, oxygen saturation level and pulse rate. It is a non-invasive and portable device commonly used in healthcare settings, home care and during physical activities. The pulse oximeter provides valuable information about the oxygen carrying capacity of a person's blood and their heart rate, making it a crucial tool in monitoring respiratory and cardiovascular health. Next is smart helmets. Smart helmets are advanced headgear equipped with various technological features to enhance safety, communication and overall user experience. These helmets are commonly used in industries such as construction, mining, firefighting, cycling, motorcycling and sports. The integration of smart technology into helmets aims to provide real-time data, improve safety and enhance connectivity. A smartwatch. A smartwatch is a wearable electronic device designed to be worn on the wrist offering various functionalities beyond traditional timekeeping. It serves as an extension of smartphone, providing users with easy access to information, notification, fitness, tracking and other features right on their wrist. Smartwatches are designed to sync and communicate with smartphones, enabling users to stay connected and access essential apps and services without needing to take out their phones. Now, let's dive deeper into some specific examples of how wearable sensors and devices are transforming healthcare and improving patient outcomes. The first one is remote patient monitoring. Wearable sensors have enabled remote patient monitoring, allowing healthcare providers to keep track of their patients' health in real time. Even when they are not in the hospital, patients with chronic conditions like diabetes, hypertension or heart diseases can wear devices that continuously monitor their vital signs and send data to healthcare professionals. This not only provides early detection to any issues, but also helps in making timely interventions, reducing hospital readmission and improving overall patient management. The next one is falls detection, especially for the elderly and individuals with balance or mobility issues. Falls can be a significant concern. Wearable sensors can incorporate into wearable devices like smartwatches or pendants to detect fall and alert caregivers or emergency services. These devices can also provide activity tracking and reminders to encourage regular movement and exercises, promoting better health and well-being. The next one is rehabilitation and physical therapy. Wearable sensors play a crucial role in rehabilitation and physical therapy programs. They track the movement and progress of patients recovering from injuries or surgery, providing objective data to therapists. This data helps therapists tailor treatment plans more effectively, monitors program and adjust therapies as needed. The next and the last one is stress and mental health monitoring. Wearable sensors are evolving to include features that measure stress levels and emotional well-being and sleep patterns. These devices can provide insights into an individual's mental health, helping them manage stress and maintain a healthy work-life balance. They can also be beneficial in identifying early stages of mental health conditions like anxiety and depression. Now, as the technology continues to advance, there are several emerging trends in wearable sensors and devices in the biomedical field. Wearable biosensors. Biosensors integrated into wearable devices can measure specific biomarkers in bodily fluid, providing valuable health insights. For instance, continuous glucose monitoring devices for diabetics are wearable biosensors that measures glucose level in real time, reducing the need for frequent finger picking. The next one is smart fabrics and textile. Advancement in nanotechnology have led to the development of smart fabrics and textiles with embedded sensors. These textiles can monitor various physiological parameters like heart rate, respiration, and even detect skin infections and wounds, making them highly versatile for medical applications. The next one is artificial intelligence and data analytics. The combination of wearable sensors with artificial intelligence and data analytics opens up new possibilities for predictive healthcare. AI algorithms can analyze large amount of data from wearable devices to detect patterns, identify early signs of diseases and personalize treatment plans for patients. Next, integration of wearable sensors and devices in biomedical instrumentation. As wearable sensors and devices are seamlessly integrated into biomedical instrumentation and healthcare system to enhance data collection, monitoring and patient care. This integration involves connecting wearable devices to existing medical infrastructure, allowing real-time transmission, analysis and communication. Here's how the integration process works. The first one is data collection. Wearable sensors collect various psychological and environmental data from the wearer such as heart rate, temperature, motion and sleep patterns. The next one is wireless transmission. The collected data is wirelessly transmitted from the wearable devices to a data collection unit, often a smartphone, tablet or dedicated receivers. The next integration can be data processing. The collected data is processed, analyzed and interpreted to extract meaningful insights. Algorithms may be applied to detect pattern, anomalies or health trends. The next one is cloud integration. Processed data can be sent to cloud servers for storage, further analysis and remote access by healthcare providers or the wearers. The last one is healthcare application. Processed data can be integrated into electronic health records system, medical dashboards or mobile applications for medical professionals and patients to access and monitor. Now, while the integration of wearable sensors into healthcare system holds immense potential, there are challenges that needs to be addressed. The first is data accuracy and reliability challenge. The challenge is to ensure that the data collected by wearable sensor is accurate and reliable, especially for medical diagnosis, is critical. Its solution is the calibration of sensors and adherence to quality standards can improve accuracy. Regular maintenance and update can address issues that affect data reliability. The next one is clinical validation. Its challenge is to ensuring that the wearable sensor data is clinically meaningful and accurate for medical decision making. Its solution is rigorous clinical validation and collaboration with medical professionals can establish the reliability and clinical utility of wearable sensor data. The next one would be data overload and interpretation. Its challenge is large volumes of data from wearable sensors can overwhelm healthcare provider. Its solution is that the implementation of AI-driven analytics can assist in processing and identifying relevant pattern from vast data sets. So, to conclude, wearable sensors and devices have revolutionized the way we monitor health and manage medical conditions. From remote patient monitoring to rehabilitation and medical health tracking, these technologies are making healthcare more patient-centered and efficient. As future professional, it is crucial to stay updated with the latest advancement in wearable technology and understand their potential impact on patient care. Wearable sensors and devices in biomedical instrumentation and sensors can be classified based on various criteria. Here are some of common classifications. The first classification will be based on the measured parameter. The first one will be vital signs monitoring. Wearable sensors that measures parameters like heart rate, blood pressure, respiratory rate and body temperature falls under this category. The next one will be activity and movement tracking. Sensors that monitor physical activities, steps taken, distance travelled and posture falls into this group. The next will be biochemical monitoring. These sensors measure specific biomarkers in bodily fluid such as glucose levels for diabetics or lactase levels for athlete. The next one will be sleep and stress monitoring. Wearable devices that track sleep patterns, detect stress levels and provide insights into mental well-being belongs to this category. The next classification is based on location of wear. The first one will be wrist-worn devices. Smartwatches and fitness trackers are example of wearable devices worn on the wrist. The next one will be clothing embedded sensors. These are sensors integrated into clothing such as smart shorts or sports bra. The next one will be headgear. Wearable devices like smart helmets or headbands used for brain wave monitoring or concussion detection. The next in this category is wearable patches. These are adhesive patches with embedded sensors that can be applied to the skin for continuous monitoring. The next classification is based on the application. In this, the first one will be medical monitoring. Devices used in clinical settings for patient monitoring and diagnostic such as continuous glucose monitors or ECG monitors. The next will be fitness and wellness. Devices designed for tracking physical activities, sleep patterns and overall well-being of individuals. The next in this category is rehabilitation and physical therapy. Wearable devices used in rehabilitation centers to monitor and aid in the recovery of patients after injuries or surgeries. The next is assistive technology. Wearable devices that assist individuals with disabilities or impairment such as wearable exoskeletons for mobility support. The next category is based on the technology. The first one in this category is optical sensors. Sensors that use light to measure parameters like heart rate or blood oxygen levels. The next will be monitor sensors. Sensors like accelerometer or gyroscopes that measures movement and orientation. The next is bioelectrical sensors. Sensors that measures electrical signals from the body such as ECG and EEG sensors. The next will be chemical sensors. Sensors that detect and quantify specific chemicals or biomarkers in bodily fluid. The next classification is based on connectivity. The first one in this classification is standalone devices. Wearable sensors that stores data locally and do not require constant connection to external devices or networks. The next in this category is connected devices. Wearable sensors that communicate data wirelessly or smartphones, tablets or computers for data storage and analysis. These classifications provide a framework for understanding the diverse range of wearable sensors and devices. As technology advances, new categories and application may emerge, further expanding the capabilities of wearable technology in healthcare. Now, as we have seen the classification, let me explain the different types of wearable sensors and devices based on their classification. The first will be based on measured parameters. In this, the first will be vital signs monitoring, heart rate monitor. These wearable sensors measure the heart rate of an individual, providing valuable information about cardiovascular health and exercise intensity. The next is blood pressure sensor. Wearable blood sensor monitors allow continuous tracking of blood pressure, aiding in hypertension management and early detection of abnormalities. The next one is respiratory rate sensors. These sensors monitor the breathing rate, providing insights into respiratory health and detecting irregularities. The next will be body temperature sensors. Wearable devices for body temperature monitoring are useful for detecting fever or hypothermia. The next is activity and movement tracking. Accelerometer. Accelerometer measures the acceleration and movement of the body. They are commonly found in fitness trackers to monitor steps taken and physical activities throughout the day. The next is gyroscope. Gyroscopes detect orientation and rotational movement, contributing to precise activity tracking and exercise analysis. The next is biochemical monitoring. Continuous glucose monitor. These wearable sensors continuously monitors glucose level in individual with diabetics, reducing the need for frequent finger pricking and providing better glucose management. The next is lactate monitors. Wearable sensors that measures lactate levels are beneficial for athletes and fitness enthusiasts to access their workout intensity and recovery. The next will be sleep and stress monitoring. Sleep trackers. These devices analyzes sleep patterns including sleep duration, stages and disturbance, helping individual improves their sleep quality and overall health. The next is stress sensors. Wearable devices with stress sensors monitoring capabilities measures psychological parameters like heart rate variability to assess stress levels and promote stress management. The next will be based on the technology. Photolithography sensors. These sensors used light to measure changes in blood volumes, providing information on heart rate and blood flow. The next is chemical sensors. In this, the first one will be sweat based sensors. These sensors analyzes sweat to measure electrolyte levels and other biomarkers. So now I will explain the most commonly used wearable devices in detail. It will be the pulse oximeter. A pulse oximeter is a medical device used to measure two vital parameters, oxygen saturation level and pulse rate. It is a non-invasive and portable device commonly used in healthcare settings, home care and during physical activities. The pulse oximeter provides valuable information about the oxygen carrying capacity of a person's blood and their heart rate, making it a crucial tool in monitoring respiratory and cardiovascular health. Now, let us understand how pulse oximeter works. Pulse oximeter operate based on the principle of spectrophotometry. The device utilizes two light emitting diodes, which is commonly known as LEDs, one emitting red light and the other infrared light, that pass through the skin and the blood vessels in the body. Hemoglobin, a protein in red blood cells responsible for carrying oxygen, absorbs different amount of light depending on whether it is oxygenated, means oxygen rich, or deoxygenated, means oxygen poor. When the heart pumps blood through the body, the pulse causes variation in blood volume in the blood vessels. As a result, the amount of light absorbed by the blood changes with each heartbeat. The pulse oximeter detects these variations in light absorption and calculates the oxygen saturation level and pulse rate. The readings are then displayed on the device screen in real time. Now, how we interpret pulse oximeter reading? The pulse oximeter provides two essential readings. The first one is oxygen saturation, which is commonly known as SpO2. Oxygen saturation, expressed as a percentage, indicates the proportion of oxygen saturated hemoglobin compared to the total hemoglobin in the blood. A normal SpO2 level for a healthy individual is typically between 95% to 100%. A reading below 90% may indicate hypoxemia, low oxygen levels, which requires immediate medical attention. Pulse rate, it also known as heart rate. Pulse rate is the number of heartbeats per minute and represents the heart rate of contractions. A typical resting pulse rate for adults is between 60 and 100 beats per minute, but it can vary based on factors such as age, fitness level and health conditions. Application of pulse oximeter. Pulse oximeter have numerous applications in various settings. The first one will be in the clinical settings. In hospital and medical facilities, pulse oximeters are used for continuous monitoring and patient's oxygen level during surgeries, post-operative care and critical care situations. The next will be respiratory conditions. Pulse oximeters are used to monitor oxygen saturation in individuals with respiratory conditions such as chronic obstructive pulmonary diseases, often known as COPD, and asthma. The next will be COVID-19 management. During the COVID-19 pandemic, pulse oximeters became the most widely used for at-home monitoring of oxygen levels in individuals with mild symptoms or suspected infections. The next will be sports and fitness. Athletes and fitness enthusiasts use pulse oximeter to monitor oxygen saturation and heart rate during intense physical activities to optimize training and performance. The next is aviation and high altitude environment. Pilots and climbers use pulse oximeter to access oxygen levels in high altitude environments where oxygen saturation can be reduced. By embracing and utilizing these technologies responsibly, we can contribute to a healthier and more connected healthcare system. I encourage you all to explore further and keep yourself abreast of the rapidly evolving field of wearable sensors and devices in biomedical instrumentation and sensors. Thank you.